Hello, hello.
Hello.
Welcome to another show, another episode of Code. Today, I'm here to learn just like you. I'm joined by my good friend, sometimes mentor even, Mario Gray. How are you doing today?
Good one. I like it. It's today's a good day to code, and thanks for having me on. We're gonna do some stuff. We're gonna code. We're gonna make things work, and break some bugs, and make
Let's
some
do
tests,
that. Let's
and
do
do
that.
some
I've heard
RSockets.
some good things. Do you want to explain, give us a little overview of what we might be seeing today?
Okay, so let's see. Can I share my screen here?
Yeah.
Let me share a screen. Oh, because what I want to do is basically, I have an application, and it's a microservices application. Okay. However, let me say that it is a microservices application until you realize that it's not completely microservices. It's more like monolithic microservices.
Okay.
So microliths. I think that's the pattern. It's called like microliths.
Sure.
So this is a microlithic application that I have. And if you can see my IntelliJ window, I have a bunch of different modules, just
Wait,
like
I'm going to add your
microservices.
IntelliJ window here.
Yeah. So most of these windows, I mean, most of these projects are doing things that are core components of the application itself. And well, because it's microlith, it means that like everything is baked into one place and then distributed amongst the individual boundary contexts. So my context boundaries are on infrastructure rather than code. So that's why these are micro monoliths, because every boundary contains a sufficient amount of information to reproduce the entire application. However, you won't be using all of it. And the particular module that you might see, like a deployment module, will only contain the modules that it needs in order to stand up an executable. So in other words, like you have index, you have messaging, you have persistence, and each one of those modules contains all of the users, all of the user domains. It contains all of the messaging domains. It contains all of the domains of the application, however, geared towards one specific infrastructure, like the database being Cassandra or Redis, right? So that's why it's micro monolith. Now that I've admitted that, the reason why I'm here today is because Spring 3 presents a unique opportunity to make RSocket services in a way that is declarative. In other words, I can describe the service based off of a service contract. And basing things off of a service contract is something that I've always looked for in terms of creating seamless client-server interactions. I want my clients to look like my servers, and I don't want to know that I'm actually talking to a client. I just want to know that I can talk to a service, right? So rather than calling a specific client, I can just call what I think is a service. And I like that abstraction. So let's take one service for example.
So this is new to Spring Boot 3.
Yeah.
So this
So
declarative client.
yeah, so we have a service, right? And let's just go into what we have a service that looks like this. At the end of the day, 4 methods: add, remove, find by, and find unique. And that's all that you need to know about a service, is that it just has those 4 operations, right? Well, going into it, I thought, well, okay, I want my services to look exactly like my clients to look exactly like my services. So what did I do? What does anybody do? They write clients, right? I mean,
Yeah,
we always write clients. You've probably written a lot of clients, haven't you?
I have. And I'm also leaning into this declarative client defined by interface. For those of you that are joining, please say hello. Let us know where you're joining from. We're happy that you're here.
Okay.
And Zarabi, hello. Nice to see you from Iran.
Let's look at a graph really quickly. What I'm trying to draw out here in ASCII flow is how things are working in terms of the client exposure. So at the top, you have this thing called a discovery, which is, discovery is like console or Spring config, cloud config server. Then you have the requester, which is your client, your actual transport client, right? If I can type in here, will it let me type? Well, I guess not. Okay, so you have your transport client, and then you have the actual service client itself. So what I'm doing is I'm actually making changes here in the requester transport client and the service client itself. So I'll be making these changes, and these will actually trickle down to the individual microservices, index persistence, messaging, secrets, and authorization behind the scenes. I won't have to make any changes to my underlying service contracts. All that I need to do is expose a new set of clients and have them discovered whenever I need them. So the point is to refactor just enough so that I don't have to, so I can kind of slip out the old requester client and replace it with this service client. So this is the old one, and the old one is a service, is a requester client. Requester backed to proxy backed. Okay. So requester backed versus proxy backed. We're going to go from requester backed to declarative proxy backed, which is the highlight of this particular hour show or multi-hour show.
Wonderful.
Yeah.
So I'll say for the audience, if you've got questions along the way, let us know. I'm going to slide off. I'm still going to be here. I'll be watching the chat, but bring your questions, and Mario, I will just jump in whenever I see interesting questions that might fit.
Cool. Okay, so you're probably wondering, okay, what is all this RSocket stuff about? What does RSocket do? If you go to this particular website here on docs.spring.io, you can find the Spring Framework docs. The Spring Framework docs are heavily well maintained, and they contain all of the information you probably need to know in order to implement something that is of your desire. So if you want to know how to use the reactive web stack or the servlet stack, that's all in here. Most likely you want integration, and integration is a great thing to use, which is I can connect any sort of protocol or any sort of application to other disparate application, and it's going to be a seamless, it'll have the componentry needed to make that bridge work. So that's the Spring documentation. Within the Spring documentation are the RSocket documentation. So Spring's RSocket support comes from a few years ago, maybe back in the 2.2 days, right? And it's evolved over time, and we've gained a lot of knowledge over the reactive stack and how RSocket and the reactive stack kind of like complement each other. And if you're thinking, hey, the reactive stack versus Java Loom, they're actually achieving the similar goals, but different trajectories. That is, the reactive stack is really about back pressure and the ability to scale, whereas the Loom stack is about scaling. It's just about like, okay, well, I have a lot of threads and I want to be able to manage them in a seamless way, and I don't want to have to create heavy, operating system threads to make that happen. So Loom will basically give us a much more efficient threading model, which reactive will then take advantage of. So if you think that reactive is going to go away because of Loom, think again. Reactive has its own objectives that are above and beyond the scope of Loom itself. And so in this case, I am going to just preface that and say, okay, well, I hear that there's a little bit of confusion about reactive and Loom, and I just wanted to make that known. Okay, so RSocket is the application, is the transport that we're going to be working with. Reactive streams is the thing that it uses as a backing implementation. These are netty RSocket streams. So that's the implementation library. Spring support for RSocket comes very out of the box. Once you go to start.spring.io, for instance, you say, hey, I have an application and it's a Kotlin application and I'm using maybe the latest, current version, and I want RSocket. You can just say RSocket and you get RSocket into your application. And likewise, in my application, I've done the same thing. I've just added the RSocket dependency with Spring Boot 3. And I get the ability to talk to RSocket servers or RSocket expose RSocket clients. The very first thing that I would probably want to go overview, if you don't mind, is what exactly does it mean to expose an RSocket server with Spring, right? And for the life of me, I can't figure out why it's so simple to expose a server, but then you expose the client, and for years it's just been kind of like, you have to write the client specifically. I'll show you that later, but the server is extremely simple to expose. All that you need is a controller. You need a controller that does something, and that controller could use, normally you're used to writing REST controllers, right? Well, with RSocket, we're writing messaging controllers. And so with messaging controllers, we use this stereotype, this annotation called message mapping, which is a messaging destination. And so every service has a number of destinations that will respond to requests. So in this case, you have like a chat messaging service. This sends chat messages across the wire, right? And so you have message mapping, message listen to topic, and you have a request, by ID request that says, hey, it just has a generified parameter of an ID. It could be a long, it could be a UUID, it could be a string, who knows? But at runtime, we'll find out, okay? And then because we're listening, we're going to get a stream, a flux, which is the type of stream that expands into an infinite amount of objects forever, or zero, a flux of messages. So the flux of messages is what we get back. And likewise, this particular service contract it just implements or states that it has multiple message mapping endpoints, and that we can respond on any one of these endpoints, any one of these mappings. So my server will start up. It will read message mapping. It will say, okay, I have message mapping. I'm going to stand up each one of these destinations, and then I'm going to eventually back those destinations with code because this here is a subclass of the mapping. Each one of these methods now are mapped, right? So this all this. Yep.
Can I get you to maybe enlarge and embigger your font?
Are you kidding me? Of course. Oh my gosh. Why didn't I ever think about that before?
I appreciate you so much.
Let's give you guys a size about.
Barry, I also watch live coding from my phone. I'm happy that you're here. Thanks for
live coding from the phone. And actually, it's soothing. Watching live, just sitting there and just watching live code from the phone is something that I yearn to do every day.
Co-working. I oftentimes set that that live stream over to the side and feel like I'm co-working. A lot of us are working from home these days, as are you and I. This is special for me.
This is true. For the server mapping, we have, like I said before, we have actual message mapped endpoints or destinations, and then we have an implementation of each of those destinations. Don't worry about the logic going in here. Just know that there's a destination that responds to some sort of request, right? And standing those up is just as easy as a standard Spring Boot application. From 0 to hero, you just say @controller, @message mapping, and you're good. Let's see what happens when. So the last part of the server message mapping is this controller, the actual controller itself, which is, I'm using the subclass method. I know people don't like always the subclassing, where I have one subclass have the mapping, another subclass with the implementation, and then yet another subclass with the configuration. But I was playing around when I was doing this. So,
Why would that be a good option? What are the cases where having that subclass for configuration would be a good option?
Well, I wanted it to be portable. So I wanted the ability to opt out or opt in to specific, controllers. I wanted to be able to opt out of or opt into a variance of those controllers. Because everything is generified in this application. I needed a little bit of flexibility to say, this index controller is going to use long, and this index controller is going to use strings. And then because it's long, I need to be able to say, here's the endpoint. The message mapping needs to, be as such, like long.index.user or string.index.user. So I needed a little flexibility in performing that, and that's why I found the subclassing method to meet my needs.
Okay.
Okay. So standing those up is as simple as just starting the server. And then this is a bigger application. So remember, this giant application contains tons of services, tons of clients. Let's get into the more nitty-gritty part, the main part that I'm trying to fix here, which is the client. So I have something called a requester factory. And this requester factory vends out RSocket requesters, right? And RSocket requesters are the thing that connect your client to a server. Okay, so what I do have is a standard, just bare bones default requester factory, something that I can just pull up and say connect to this server, and then give me a requester that's connected to that server. I also have the ability to do other things with my requester factory, but those are beyond the scope of this here talk. What you do need to know is that you have to have a RSocket requester in order to talk to an RSocket server. In order to create an RSocket requester, you need something called an RSocket requester builder. And the RSocket requester builder does things like it helps you support the setup data. You might have trace data that needs to get pushed into a RSocket request as it moves along the wire. So doing things to allow the proper communication between client and server is something that the requester is going to help you do. So you can extract data, you can push data into the header, you can create setup strategies, and you can basically talk to your RSocket server in a way that is simple and conventional.
G asks, how about Spring Data Cassandra, maybe reactive way? Something that we can maybe get back to later.
So, okay, that's good. But we're using this project, actually the project uses the reactive driver for Cassandra. So we could show that a little later if that's warranted.
That's a great idea. Good question.
So I'm looking at a bean. This bean basically exposes a reactor, RSocket requester, given a service key. Now because my application is a bunch of microservices, I might connect to multiple hosts, and I need to know the name of the actual service. So I have to give it hints to say, hey, I want to connect to index, or I want to connect to persistence, and it needs to know where to find index, and it needs to know where to find persistence. And so that's why I have all these extra methods in here, like get service pair, things like that, because those can be baked into your application startup time. All right, so basically, we're looking at the requester factory, the way that I get requesters out of my application, and then we need to get into the nitty-gritty of how did I actually implement the client. Given a requester from somewhere, I have a client. And that client can be a bunch of things. First of all, I have the index client, which is a thing that allows me to talk to an index, like a Lucene index or an Elasticsearch index. And this is my own application microservice. And so I have these functions called add, remove, find by, and find unique. But in order to get an index client, I have to feed it a prefix, that is the destination prefix, which is usually going to be index dot, but it could be something else, depending on what your deployment looks like, right? But I want that flexibility. I want to be able to say, okay, well, I don't know the destination prefix, so I need to add that at runtime. So that's why we enumerate that here. The next thing is the actual RSocket requester itself. Like I said before, if you know what connection you're going to use, if you say, hey, I have this requester and it's connected to the index microservice, then you want to hand it that particular requester. So that's why we have requesters backed within this class implementation. That requester is then made to do things. I have to write, manually exactly what's going to happen and say, okay, well, requester, send a message to this particular route, and whatever the prefix is, and dot and whatever the suffix is, which is add. And add is essentially give me push something into an index, right? So it's going to index something, and then give it the payload. I have to say, hey, give it the payload, and then retrieve the thing that comes back. If it errors out, I'll know. But in this case, for this particular method, nothing comes back. We just hope that it's fire and forget. So it's either going to error or it's not going to error. We're good with that. So we have multiple functions that we have to type manually. I had to write this manually. And that takes a lot of time because if you notice, I have quite a few clients.
Who wants to do that? Who has time? Who has time?
Who has time?
That's
right.
a lot of typing.
Yeah, and who has time to write all these different methods that are essentially the same piece of code over and over and over? And so I would like to be able to skip all of that and then go straight to the implementation of the or go straight to the client itself with just a hint of what's needed to get from point A to point B without me having to write all this stuff. I don't want to have to write a whole new subclass to make this work. So Spring Boot 3 allows you to do that. It allows you to get around having to write manual requester code. And it allows you to write something that is more, more, what do you call that word? Declarative. Declarative is an awesome word because for the life of me, I've always written HTTP code, and every time you write HTTP client code, it's like you can make a mistake. And then in order to prevent the mistake, you have to write tests. And then for those tests to work, you have to test everything, right?
Yep.
And so we have lots of tests in here. Everything in this module is tested to the teeth. Well, just because we need to be able to ensure that every single component that I wrote is going to work. So for instance, a test for a microservice that is an RSocket service and its client, it needs to be able to at least stand up a controller. And that controller represents some, mocked state of what will eventually get served, right? We don't need all of the components. We just need to be able to stand the controller up in its service destinations. We need to be able to talk to service destinations and receive answers. And we need to know that the typecasting and the serialization of going across the RSocket wire is indeed what we're expecting. And that's why we have so many tests here. First of all, writing tests for RSocket is not hard. You just need a requester, and you need to stand up a controller. In this case, this is a message index test. This thing talks to a index, a Lucene index, for instance, or a test index that is mocked. And it says, hey, I have this particular set of destinations I want to test, add, remove, query, unique. And each one of these unit tests, will do that. So for once, you'll have a test that says, should query for entities. First thing you do is you mock out the service because we don't need the real service. We've already tested the real service somewhere else, right? So those become a mock beam, right? So we'll back the actual controller with a mock service. Second thing is actually perform the call out to that service using our client. So what we'll do is we'll talk using just the requester here, and we'll say, okay, requester route to query, and then here's some data to route it to, and then you're going to retrieve a flux of keys. And so, of course, given this BDD Mockito setup, the underlying service will just return a bunch of like this stuff here. It'll create this. It'll return what is a message key.
So what we're doing here is we're kind of showing a different approach, right? A couple episodes ago, we showed the approach of using mocks to validate and test and drive our documentation. I think we came back. Maybe we didn't. Maybe I did that on a different show. But the idea is we can also use test containers. And drive against an actual implementation. So instead of providing some message that Flux will return, we can actually have an implementation backed by a test container, and we can do it that way. So over the last few episodes, we've kind of showed a bunch of different ways that we can kind of attack this testing of our different clients against our services.
Yeah, I like the idea of test containers, and that's run across my mind a lot, actually. As I get towards production, I want to be able to verify actual key services. So I want to be able to stand them up and say container, fill them with data or not, and actually ping them. And so I'm going to do that later in terms of the cycle, the evolution cycle of this current project is create acceptance tests, actual acceptance projects that stand up individual services, test them, and then say yes or no, green light, red light.
Can you show me your POM or your build file? Are we pulling in any interesting dependencies that we might not have pulled in before? Or is this pretty straightforward?
It's pretty straightforward. The two key things here that we're going to use, because we're using Kotlin, we need Kotlin libraries. But the key libraries in testing, like RSocket, for instance, are just the JUnit Jupyter engine, because we're using JUnit 5 and its extensions. And then, of course, the Spring Boot Starter RSocket, which brings in our requester and our ability to stand up services. And then finally, these last two here, which is the Spring Boot Starter test, which brings in all of our, extension, Spring extension, that class, things like that, and our Spring Boot application test or Spring Boot test. And then we need to be able to test reactive streams using the reactor test dependency.
Okay.
So the only thing that I use here really is step verifier. And step verifier allows me to kind of, step through each reactive, each little part of the operator. Each operator I can then visit and attest. And I'm kind of doing that here. Step verifier create stream. This is the stream. That's a client callout, and it's going to retrieve the service response. And then I can assert what's going to happen on the other end. And I'm using an assert J. Assert J comes with Spring test, with the test dependency here. That is Spring Boot Starter test. It comes with assert J. So I don't need to add anything extra for that.
You have a question here saying, would you push this project to GitHub?
It is.
I knew the answer to that one. It is. It's available. It is a project that's been iterated over many, many moons, and it's always fun. There's tons of examples in this repository. You definitely need to take a look. But yeah, thank you for sharing that.
There.
I will add that to the chat. Would you mind maximizing your IDE so we can kind of see a little bit more of the lines that you're showing? But I will put that repository into chat. And then one more question, because we've been spending a lot of time, or we have spent time on REST docs. And in my head, I'm wondering, with an RSocket implementation, I have my requests that I'd like to be able to validate. I also have my my services. It's a two-way street. I have to define and explain both ways. Not to off rail or take this off track.
I hear you.
What might that look like? That's where my head's at. What might that look like in my documentation, as I'm not just defining a request and response? I've also got kind of a two-way street request and response. There's multiple ways I need to be addressing this, and can we do it in a similar way to what we've done in the past? So yeah, I'm just thinking that out loud.
Allow me to let me do something real quickly.
Okay.
I need to. What I like to say is documentation. I'm not 100% on the documentation of like we have REST docs. I haven't had any luck documenting my RSocket endpoints, but only because I haven't looked in that area myself. So it's something that I'm going to want to look for in the future again. Providing that I can, if I could produce docs like REST docs. Great. Currently, I don't know any way to do that. So I'm going to we'll have to maybe research a little.
Yeah, because what RESTdocs is doing is it's capturing the request and the response. What we would probably have to do is create that extension, just like we do for our RESTdocs with Mockito or with Rest Assured. We probably have to create an RSocket extension. So while you continue forward, I'll look and see if we have one.
So and it would have to listen to the wire and say, okay, well, what are you sending?
The repository here is demo chat, right, on your GitHub?
Yeah.
Right, I'm gonna put that in
called demo chat there.
All right.
So so I'm just testing. This is a simple test. If you notice, maybe you can see this, but you see the wire protocol in tests. So you're able to see like what's it sending, what's it receiving, and you basically need to be able to decode this and then create documentations based off of what part of the request response cycle or stream cycle is happening. Because like you said, it's reasonably more complex than just REST, which is request response. I mean, you have two-way streets happening. Your server and your client are symmetrical. That can be symmetrical. In other words, the server can make requests to the client, and the client, of course, makes requests to the server. And then how do you document that? How do you engage the ability to say this server will make a call out to the following endpoint? How do you do that, right? So there has to be an extension that does that for us. Okay. All right. So this is my requester tests. There are further actual tests that involve a client. I believe that is production. Let's see what we have. Queue service, requester. These are all requester tests. Where are the? Okay. All right. So yeah. So that was a requester test you saw a second ago here, which is just, we're going to, use, well, don't worry about that anymore. That was the last thing you saw were requester tests. The next thing is the next level up, which is the abstraction of the service using the requester as the thing that does the work. And of course, that's tested as well. So I need to be able to write my proxies in a way that I can just go ahead and reuse these tests. So I'm still using service contracts here. In this case, rather than using a requester directly, I'm just talking straight to the actual service prototype right here, which is the message index service. My eventual test target will be, the service, the client-backed service versus the controller-backed service. That's my goal here, is to be able to just make a client call out and have that client call out work exactly like it did before, which is here. So I have client equals message index client, and I gave it the service prefix and requester as my configuration requires, and it does the work. So it does all of that stuff. It does requester in the background. So as you saw, I did requester tests first, because those are the raw tests. That's not exactly required, but I like to be able to test the fact that the controller is still responding before I write my tests for the client. So that's why I wrote 2 levels of tests, one using the backing client and one using the actual client that I'll expose later on, right? So we're going to move on, and we're going to say, hey, I have this idea that I want to create proxies now. I don't want to have to write requester code. So what am I going to do about that? And that's where the new stuff comes in. That's where the new the new goods come in with Spring Boot 3. And we have this document, this fine RSocket document that I don't read enough. I really don't read enough of it. I mean, it gets better every time I open it, and I learn something about something new. There's something always coming up and making me go, oh, okay, I could totally use this for all sorts of various nefarious use cases. But my current nefarious use case is the RSocket interface, which is going to let me do that whole declarative client thing. And so it's in this document that says you can declare your interfaces, and your methods can have RSocket exchange and then the given destination. So this is cool. So all I have to do is create an interface of my service and then annotate each one of the methods with RSocket exchange and give it the controller's destination. And I'm good.
Yeah, this is awesome. This is like it's like Lombok, but for our client. It's like, hey, here's your thing. We know what it's going to take. We know all the boilerplate code underneath, and the Spring team, they're just taking care of it for us.
Yeah. So like there's a couple of things I need to know about first, like destination variables, add a route variable. Let's see. So this route variable is going to pass to the RSocket requester along with the route from the RSocket exchange in order to expand template placeholders. Of course, in the route, this variable can be anything. Great. I have a payload. So I can pass in the payload that I'm going to actually send with the data. And then I have a method argument object followed by MIME type. Okay, so I can use object followed by MIME type. Okay. So MIME type can be any object as long as the next argument is the metadata entry MIME type. Okay. So I can set the MIME type. I might have to play with the MIME type a little bit because I do have specific encodings, but I don't have anything beyond text currently. I imagine if I wanted to transfer an image, I would have to play with that some.
Mm-hmm. We ran into the MIME type issue on a previous episode. That's fine.
Cool.
We understand.
Cool. So annotated RSocket exchange methods support return values that are concrete values or any producer of value that can be adapted to a reactive stream publisher via the reactive adapter registry. Cool. We're not going to write adapters because we don't have any special, underlying transport code or underlying thread-bound, operator code that we need to worry about here. We're just going straight from flux to flux, so it'll do all of the correct translations for us. If I was using NetEase or Netflix's Flow and Netflix RX, I guess if I was using that, I would need a reactive adapter registry to go between the RX Java and RSocket. But in this case, we're doing vanilla RSocket with vanilla reactive. Okay. So there's nothing extra except for the fun part, which is me just defining a client. And that I started doing that here just a minute ago. And the reason why is because I wasn't quite sure how it's going to react to me saying I have types, I have generics, and I want you to respond with the knowledge that there are generics coming back. Now, I'm surprised to know that it's still, there are some things to do. So for instance, in this key client here, you're looking at this and you're thinking, okay, well, you created a client already that uses the proxy, and that's fine and dandy. Simply just go RSocket proxy factory builder, here's your requester, and then build the proxy itself, and then create the client, right? So that seems fairly normal. However, my key proxy is a key service, and RSocket exchanges are annotated through this key service. So if you notice, I have my iKey service, which is a service interface, right? Mm-hmm. Let's see. We can go down to here. Here's the controller mapping for it. So the controller mapping is just iKey service mapping of key service, and it just has, your destinations, key remove exists. Likewise, the key, the declarative client just uses RSocket exchange. However, if you notice, I've already baked in the prefix. So I'm going to need to find a way to unbake the prefix so that I could make it an option. So I don't have to have the prefix, or I can change the prefixes around. But for now, this suffices as a POC, as a proof of concept that, okay, proxies are available. I could make proxies work with this. So the first thing I did was I just created that proxy underneath my hard-baked, requester. This huge class that does a lot of work, that's error-prone, that I have to write test cases for because...
Get that out of here.
Get that out of here. Basically, I want to be able to delete this.
Get it out of here.
Exactly. I can effectively delete this and call key proxy key client, and it will take over. And so that's the happy medium there. It's just replacing it with the thing that I want to do the real work. So I wonder if I can do that here.
So while you're doing that, just a reminder, like this is code. Right now I'm learning just like you are. We are trying to show like what it's like to use the Spring framework, how we actually are developing day to day. Hopefully it looks familiar. Yeah, I use it as a kind of co-working opportunity, but it's also you get to ask questions. So if there's something that you don't understand, there's a question you have, whether it's related to what we're doing or not, please ask. We are both Spring developer advocates. Mario obviously clearly is a Kotlin expert as well, but we're here to answer your questions. We're at your service. So if you've got any questions about anything, yeah, drop them in the chat and we'll try to get them answered.
Okay, so what I'm doing here is I'm taking what I have in terms of what the key client did, right? Which is create the proxy for the, for that key proxy class, which is the client. Actually, I should call that, instead of key proxy, I should call that key client. Or what would you call this? What's a better name for this?
The key proxy, I kind of connect the dots that the proxy, yeah. Oh, that works.
Okay, we'll just call that key client proxy. And then we'll call the other one persistent store client proxy for now.
Okay.
For now. These are shims. This is a shim. This is mostly a POC so that I can understand how to implement the generic form of service pattern that I'm using with declarative clients. So I will create this class. And do not put it in tests. Okay. All right. So back to production. So I have my core service proxy beans, which expects to be able to create a persistent store client proxy. And this guy here is going to be a, I have my service definition here. Oops, T and U, no. E is entity type, I'm sorry. It might be mad that I'm using E instead of U, but E is specifically the entity. And so I can remove these. Oh, in fact, this isn't a class anymore. This is an interface. I'm sorry. So this declarative client is an interface, and it has no implementation. And I can use RSocket Exchange. Oh, wow. And what I want to be able to do is say $, prefix. And I don't have a prefix yet, so I need to be able to parameterize that. Maybe, maybe not. We'll see. Not seeing that. Oh yeah, because that's an interface. What am I going to do with that? Okay. So I have to be able to suss that out somehow. So let's just do this.
Yeah.
Persistence.key. The next one is persistence.all, I believe. Let's just make sure that I got that right. Controller. There we are. Mapping. Okay, so key, add, remove, get, and all. So I have key, add, remove, get, and all. Key, add, remove, get. Okay, there's all. Let's get rid of this implementation. We're not going to need that. And let's get rid of that implementation. Let's get rid of that implementation. And okay, so remove all the implementations. Let's go ahead and push in this guy here. Now, this is looking really better already. I don't have that much code to write. I have to only think about how does my application interact with it, given the prefix.
Deleted code yields no bugs.
Yeah, and then pretty much just map this using my proxy bean factory or my proxy beans. So this is already done. I just wrote this code a minute ago, which does RSocket service. It makes the proxy itself, create client. This is what actually does the job of turning your those interface methods into requester backed methods, given the hints of your class of the socket exchange. So the next thing I'm going to do is so I have a key here, and I believe there is an annotation that I need to use to make that work. So I believe that's payload. Okay, so I have payloads here and here. Okay, so maybe that works. Maybe this is enough. Maybe I'm missing something, but we're going to find out because what we're going to do is we're going to write tests for this specific one.
We like tests. I like tests. I hope
Yes.
you like tests. Tests are good.
And then the test, I had the key proxy tests. I'll call that key proxy client tests.
We're gonna be able to use our same tests. We're not gonna have to rewrite any tests because you already had tests for the requester client.
This is true. Yeah, as a matter of fact, the only thing different that I had to do to make the client work was call this guy here, core service proxy factory beans, and then give me a key client. That was it. So ostensibly, I can just take this guy here, which does the same thing, only it creates, it does the old version. I could just replace that with the new version and rerun these tests, and they should all work.
That's what we should be doing. This is an experiment, right? This is something that whether you're doing this or other, the idea of, hey, I've got tests in place. I want to try something new. I want to bring some new anything in. I want to do an experiment. If I can validate that experiment by using the exact same tests, then that helps to get approval for whatever you're trying to do. So it's one of those things that it's a common pattern I like to play. It's like, hey, if I've got tests, I've got a way to measure the outcome as we're doing it today, like the test that you're looking at, and I want to try something new. I think that we can delete some code by creating this interface, declarative interface. We can delete some code and have the exact same output because I've got a good test suite, and I can run those tests and I can validate it. Hey, manager, leadership, whoever needs to approve it, can I run this experiment? And if at the end of the experiment my tests pass, can I delete a bunch of code? And the answer should be yes, as an easy way to get to yes.
So that's the idea, right? It's just, I love having an excuse to delete code. Like refactoring makes me, sometimes I get a little bit too eager and I start deleting code and then going, okay, maybe I don't want to delete all the comments.
Yep.
Comments are code, no? Okay, maybe they are. Maybe they are.
Are you trying to get into a political battle here? Like,
yes.
Like, whoa, we're just trying to code.
Okay. So, all right. So we have the new form. So the key tests work. So this thing passes how key tests work, right? And where is key client? And let's see. I didn't do this. What I didn't do is I didn't specify payload. So I'm wondering how, when you say works, what does it actually mean? Is payload actually required? Is payload actually something that I misread? What is payload? Specify the input for the request.
The payload
already producer values.
Yeah, the payload should be defined where you're defining your exchange, right?
Yeah. Yep. So that's exactly what I expect to be able to write there.
Yep.
So that's what I'm doing here. Let's run that test again.
Okay.
Key tests. Okay, you.
It looks green.
Yeah,
green. I can't see it all, but it looks green from what I can see. Green.
That. Let's see what the wire. Let's see what the wire is. Hi. So wire protocol, it says key.remove key bpid. Okay, so there's a key. There's this empty response that I'm getting, of course. So it's sending a key, and then it's sending a empty response, which is what kind of I expect. These tests are very simple. They just ensure that things are being transmitted across the wire, and that if I send something, I should receive something. But what they don't do is they don't specify state, because testing state in unit tests is kind of hard. And it's something that you only want to do when you really have specific needs for it. In this case, I should say that serialization is a big thing for this project, and I set up serialization differently. I created object mappers for everything. I created ways of taking JSON and turning them into the objects very, very, very specifically. So I didn't let the machine do that for me. I did that myself, just because a few years ago when I wrote this, the support for JSON serialization for generified object data classes was like brand new, right? So I just wrote my own object mappers at that point. In any case, those are working in the background. Is I can see that those are working in the background. And what I want to do is eventually get rid of those old JSON deserializers and let the framework do the work for me. Because I know that today the work will happen for me. It's just back then I had those serializers working, and they're essentially doing the same thing. So
I'm going to delete that code.
Okay, so it's extra cruft that I can then delete later on. So it's refactoring, and we're just refactoring RSocket requester to declarative client, and this seems to be working pretty well. I like the way this is going, and I have no idea why this is so easy, but it is, and great. So yeah, all right. So let's go ahead and see what else we can do. The next thing we did was we created a persistent store. And then we're going to go into our persistence tests, and then we're going to replace the persistence store client with our proxified, with our declarative client, right?
We're going to have to do the same thing on our persistent store client proxy, where we're going to have to add the payload to each of those methods.
And there is an object that actually vends these things. It's called core service proxy beans. UUID is the key type. And I want to say persistence client, and that is user of UUID. So I have these types all over the place currently right now, and I'm not exactly a person who would like to specify types directly this way. So I'm going to see what's going on. Core service proxy beans UUID. Oh, my bad. That needs a constructor. So currently I'm constructing the proxy beans. I can probably just create an instance of this here, since I'm already typed to one specific key. The reason why you're seeing UUID everywhere is because UUID is the type of data that a key represents. So a key is just like your ordinary, MySQL, auto-generated key or auto-incrementing key. In this case, we're just using UUIDs as the data within the key. So I need to be able to say, okay, well, every time I receive an object, it's going to have a key of some data type, and currently it's UUID. Okay, so we just create an instance here. Now we don't have to create an instance every time. And there we go. So we're going to copy and paste this code. Now, the reason why some of this stuff is repeated is because, well, some of it's worth being repeated. Sometimes code is, especially in tests, the more test code I see, the more I realize that it could be beneficial to repeat something so that you know exactly how the test is set up.
Could I do this in like at before all method?
Yeah, like what do you mean? Like create the beans or create the client?
Create the client. Because of the instance, I want to have a handle on that instance. So never mind.
Okay,
it would be a slightly different.
All right, so I'm going to cross my fingers here, okay? And I'm going to run this.
Okay.
Don't worry about this. This is like state data. Nobody needs to worry about state data. In fact, I don't need to worry about state data.
We're not talking about that right now.
I should create this will be better in a companion object, and it'll just be static data because it's state. But for now, let's go ahead and run this with my fingers crossed.
I mean, we're live. What could possibly go wrong?
I don't know. Exactly.
Right.
Well, I think one thing going is all of my routes are wrong. I don't think I have the right routes.
Well, go back to your interface where you set the exchanges and you didn't pass in the payload body. Oh wait, maybe you did. Yeah, never mind. I can't see all of the.
Oh, okay. So I am dealing with a class cast
exception. What are we doing? I get it. What are we doing? We're jumping in and we're doing RSocket and we're testing. We just we've converted a requester into an RSocket declarative client, a declarative interface, and the client is built for us using Spring Boot 3. And now we're testing it. We're testing it because RSocket allows us to do both ways. So we tested one part of the client, now we're testing another part of the client. And we're updating our tests that we already had existing, and we're deleting a bunch of code.
Yeah, so I'm imagining that the mileage I get out of the more complicated scenarios. So I have this complicated scenario where okay, of course that's going to work because that was the old code. I just wanted to make sure that I wasn't getting decompiled data or things that are not like within the right compilation unit. So like I might have used a different JDK at some point, and sometimes the different JDKs bytecode get mixed within the IntelliJ's memory, and it thinks like, hey, that's a different JDK. I have no idea what that is. I'm not gonna, this thing is gonna fail, right? So essentially, we're good. We're still in JDK 17 here. However, I did get a thing. So let me see what this looks like. Application cast, dirty's context. What is all this stuff about? Spring test application cache statistics. Okay, cache statistics. Before test method should find all user class annotated with dirty's context, false with null method. Okay, don't worry about that. That's not even a warning. That's just debug. Okay, yeah. So the meaty error is loader of app. Persistence is an unnamed module of loader app, so cannot be class. I cannot cast to this class. That is a error that it looks hairy. That is a hairy error. Remember, this is an advanced form of this kind of use case. Maybe this is the wrong use case. In that case, getting a persistence client with generic form with generified arguments, and then casting it, no less. Like, you see, it's this cast that should scare you, because anytime you cast an object, you're saying that, well, I don't know if this object is a thing that came out I don't know if this is actually backed by the thing that I'm asking for, and you're just force casting it. Although it worked for key client proxy with one generic parameter, when I bump it up to two generic parameters, that is the function E having its own parameter, it then begins to bug out. So my next thing is to do this. I'm going to get rid of the generified parameter from the core service proxy beans, and I'm going to put them into the functions instead. And in this case, I can do T comma E. So what I will do is I will go back to the key client tests. In fact, I will go back to this key client test here and say there are no more generics within the proxy bean anyway. At least we don't need them here. They really need to be on the function. And let's do this. Let's do that thing we did earlier by pushing our proxy beans up front. Okay. So then I can just say service proxy beans dot key client, and same here. There's only a few places where I have to really change that. Okay, so now we're looking good again. We created our proxy beans, and then we went ahead and turned them into a.
And we expect this test to pass.
Oh. Yeah.
All right, so we have a.
Oh, that's right, because the other stuff. Yeah, everything else in here has got to go. So all of these things here. Whoops, key tests. Yep, because we changed two tests. So I could get rid of key proxy tests. I guess that's what I should do. I was looking at key proxy tests. That was the first genesis of can this thing actually work? So the first code I'm going to delete is right here. Goodbye.
Awesome.
Boom.
Deleted code. No bugs.
So let's create that. Let's do this again. Get rid of that annotation. That generic, because we don't need that anymore. And then let's just change this guy here
So what we're doing right now is we are taking away the generic because we weren't really using it anyways. We're taking away the generic and we're going to rerun our tests.
Okay. Well, let's retest this, and let's ensure that like the generified function is giving the right hints to the thing coming back. And there's this too, core service. Okay, this is the user service tests. Okay. Is there anything else that I need to worry about now? Are we good? Yeah.
Oh, there's another one.
Okay. So this is going to get a little bit more hairy because I made all these changes up front, and I'm going to delete
Refactoring.
that. I really want to just get back to my key client and ensure that it key tests and ensure that it works, and find out. I think I'm missing something, so I'm going to hope that this turns green. First of all, okay, that did good.
Still successful.
Okay, I like that. So I like the fact that it was able to send the string back. Let's see what else. What are we missing? Let's do this.
Okay.
I want to find out if this is actually doing the right thing. So I'm going to do that, and I'm going to look at the output of RSocket.
Okay.
That's all. I'm going to say, okay, well, I know what the request looks like in the new version, but did the old version look like this too, or did it have like a payload that I'm missing? Am I not seeing the payload? Because okay, it's the same payload.
Looks the same.
Okay. All right. Okay, good. So
all right, you're back.
What I wanted to, that's just to find that out. Okay, so I saw that. This part gets a little hairy, DaShaun.
Yep.
This part gets a little bit hairy. The reason why is eventually these clients will be exposed as conditional beans. You'll be able to turn them on and off depending on the deployment style, right?
Yep.
And for now, if you can see this code here, I might need to go to the maintainers and make some, hey, how do I get to this point where I can proxy a generified target rather than just a standard, non-generified
Sometimes,
target.
Mario, you ask too much. Sometimes you ask too much. What we've done already today, we were able to delete some code, and we verified that by using that declarative interface to generate our RSocket client, that we can do it, and we can throw away a bunch of code, and we can validate it with the exact same tests.
Yeah. So as I see it, this is very simple if you have one type argument. When you have multiple type arguments, you might be getting into some hairy things that require extra lifting. So we want to be able to lift that extra type argument and then say, here's the secondary type reference or the type argument that we're looking for, because that might not be happening here. And if I force it here, I'm not sure if the code does the right thing to say, oh, I see you forced, you're typecasting your persistence controller store proxy to a UUID and user UUID. So I need to know that the RSocket requester on the other end knows this, because I want it to be able to see, okay, every payload's going to be whatever E is. And it's going to be able to take an E and deserialize it to whatever object E represents. So in this case, if I go back into persistence tests, and I'm going to turn on one test. I'm going to turn on one. It's the add one. So the add one is just me sending data over the wire and then getting like an empty answer. So it's really the simplest. It's really one of the simple ones.
Okay.
There's no stream of data or anything like that. And oops. So a persistence client has two generic forms, okay? Really three, really two. Don't look at the enriched stuff. Just look at the first one.
You ask too much.
Right. So you have like, user topic. These are all the things that can be persisted. T is the key. User of T is the entity data that will be transferred. In this case, I'm testing a user persistence. And so because user persistence is already typed generic or typecasted to a user, I might be able to get away with just using the user persistence of T in the proxy. but that fixes me to the specific that fixes it, and because it's going to be fixed to user. I don't want to do that. I don't want to have to just make a bunch of implementations of this with each one of my data types. So for instance, it will look like this. Can I just do that? Yes. So I'll fix that to T anyway, and see where we can go. So let's implement. Let's override. How do we override? How do we tell it to override? We say, hey, go ahead and start implementing all of these things.
Right click, implement. There you go.
Oh, no, I'll just copy and paste this. That's fine. I could just copy and paste all this.
Wait, didn't it work? The implement.
I created something else. I wanted the body.
Right, because the implement interface would have given you an impl class.
Yeah. So out means here's my lower bounds. It's user T. Everything should be a user T. That's all. It's just lower bounds. Okay. So now that we got rid of one argument, one generic argument, we could probably suss out that, okay, well, if I use the user persistence client's proxy, instead of just a generic persistence store, then I might be able to get away with having those arguments kind of collapsed. And then if I can do that, then I also need to be able to say, I'm going to keep persistence client here just for now. Just okay. It's going to hang out.
I'll allow it.
It's just going to hang out. Let's see. Actually, no, it won't hang out. Let's blow it away as we should, as one does their code. And so this is called user persistence proxy store. Oops. And that's just one generic now. Okay. So now this persistence client represents a very specific store.
All right.
And again, I have to now go back and write these tests somewhat differently. I have to get rid of the second generic parameter. And this is actually expecting a user persistence. And user persistence takes one argument, not two. Okay, so that should just about do it for us right there.
Okay.
Let's try to run that. Let's see what happens. Oh, you gotta implement something, my friend. Where'd you come from?
Yeah, when we did that, right click implement. Sorry.
I right click to freedom here. So yeah. Okay, let's go back there. Come on, don't give me. Oh. Yeah. Okay. So that's part of the routine.
Yep.
And it's the same error, which is good. It basically says that you can't collapse that extra generic parameter, since RSocket probably doesn't know what to do with it. It's probably going to say, hey, you're giving me something that this is just an object, man.
Yeah.
And this object, where am I going to load it from? So cannot cast it. I shall do the following. I don't even know what this error actually means. I'm going to find out what that actually means using Google, because or ChatGPT. Which one?
Yeah.
Who do you think knows it better?
Well, now Bing is where we're supposed to go, right?
Bing.
Tell us to go to Bing so that we could use ChatGPT. But we know what ChatGPT is. Is that it's not all the way current.
Okay, I'm maybe your skills at Binging are, well, obviously better, because I think this is the first time I've used Bing.
Yeah, Bing is a verb just like Google is. You gotta Bing it.
Does Bing have ChatGPT built in already?
I thought I don't know. I didn't read the news. Dan would tell us. I don't know what's happening.
Okay, unanswered question. That's a new one. This is probably a Kotlin specific error, which then starts bugging me, because if that's a Kotlin specific error, then what do I do?
It's okay.
Creates delegates. Oh, right. These are the proxies that are being created. Ha. Okay, so these are JDK proxies. Okay, so somebody's creating JDK proxies, and it's unable to cast. It cannot cast my particular interface to that proxy. Aha. Okay. All right. I'm going to think about this in a slightly different way. I'm going to go even further. I'm going to get rid of all of the generics. How do you like that?
I think that's okay.
Okay.
That's okay. We can use an example. You were doing the plus version.
Yeah. I'm going to start here.
We're doing it live.
I'm going to start here. Yes. So what I'll do is I'll start here, and I'll say, hey, I actually have no generics anymore, guys. Now you should be able to work, right? So this is bound to a specific key type, which is fine for our tests. And I don't have to worry about what's coming back over the wire. Actually, this should be persistence store. Oh, you know something? I have another question. I actually have something else to prove.
All right, tell me.
I have two things to prove here. One of them is I don't think I got the route, the controller route correct.
Why did you say that? Oh, wait.
Here we go. Resources. What's in here? Okay, there's nothing. Okay, oh, that's production. Let me get a production. Oh, hi. Did you just?
I didn't do that. Oh no.
Did you just? Excuse me?
Oh boy.
Did you?
I didn't. It wasn't me.
Did it really?
It wasn't me. Oh boy. Awkward.
Wow. IntelliJ just said, yeah, man, like I see what you're trying to do, but like, nah, like you read some more. You're not done reading, buddy. You're gonna have to ask questions again in the nitty-gritty, which is fine. I'm going to try to prove something and see if it works. Maybe it doesn't. Maybe it does.
It's okay.
And if it doesn't, then I'm not going to spend all day trying to. I'm not going to talk to people in front of you guys. I'm just going to go straight to the Cassandra stuff. But as a proof of concept, I know that some things work, and more complex things are more complex.
For what I wanted to see today, we checked that box like 20 minutes ago, so I'm feeling pretty good.
Is this right? Did it really just rewind? Did my code just get rewound? IntelliJ, did you like forget to save things?
IntelliJ did the eclipse and randomly stopped working.
Oh, it didn't even pick up the changes. Oh, that's scary.
So
usually it picks up changes. It goes, hey, it's changed here. It's going to change on disk. IntelliJ was doing none of that. I might have pissed it off.
Well, how about this? How about let's just pause for today. Let's pause. We've kind of like went down some holes and we don't know what got saved and written. So to unwind to where we thought we were or think we were, that might be a little tricky.
Okay.
How do you feel about that?
So
is that all right?
That is okay. What do you have?
I think we just pause. We can just call it good.
All right, let's get now.
I'd like to ask a couple of questions though.
Go for it.
RSocket. This idea of a two-way street. I've used it in the past. What are like those key use cases where I'm thinking, hey, this is really a good use case for RSocket? Can you give me a couple?
So like, if you have a client, say you have a mobile phone app, and you want your mobile phone app to be able to make health requests to the actual client. RSocket has that bidirectionality so that you have symmetrical client server. And because of that, if you're on a mobile phone client, usually mobile phone clients aren't like the web where you don't know if it can do this or you don't know if it can't do that. You have the understanding that both are structured in the same way.
Mm-hmm.
And you really don't have to worry about whether you can or can't. You can just do it. If your server implements a certain functionality and your client does as well, a mobile phone app maker will make it so that the server knows that the client can do these things, like a health check, for instance,
Mm-hmm.
or how long have you been scrolling through this particular range of tweets. It'll be able to ask the client that. Instead of the client having to push that data, the server can then ask for that data.
Okay.
So that's one good thing about RSocket. The other one is it's multiplexed. If you have any like understandings of why multiplexing could be good, I think gRPC, it's pretty much a multiplexed protocol. You create one connection and you make all requests through that one connection. That prevents you from having HTTP type issues where you have a number of connections per request, right? Like everybody has to create their own TCP socket with HTTP, but until you get to WebSockets, and then you can start multiplexing things.
Mm-hmm. But
so,
RSocket is not WebSockets.
Hmm?
RSocket is not related to WebSockets.
Right. RSocket lives above WebSocket. So you can use WebSocket as a transport for RSocket. So rather than just, by default, I use TCP, right? So like if you look at what happens here, I like TCP IP. Why do I like TCP IP? Well, it's just everybody has TCP IP. What we typically do is create a TCP listener, and if you want to secure it, you can secure it with like SSL. It's very simple. It's something that I would advise everybody to do. It's in my security module. So there's a security module that sets up RSockets, PKI security, so that you can use, certificates. You can use a self-signed certificate, or you can use a VeriSign signed certificate to ensure RSocket communications are 100% encrypted with your stuff. So eventually, you would bake the fingerprint into the client and have the server, issue a trust factory for its own connection that uses its own private key that the client can then verify, right, with the fingerprint. So this allows you to make not perfectly, but encrypted connections between client and server, and a very small amount of code. You don't have to do too much to make that work. Just understand how cryptography, what type of validations you need, what type of trusts. Do you have a trust file for your downstream keys or not? And basically rotate your keys. Like, do you have that operation down? So securing things is just another completely separate strategy. TCP versus WebSocket. WebSocket is closer to TCP than it is HTTP. All WebSocket is the upgraded version of HTTP. So whenever you make an HTTP connection, you can say, hey, I don't want to have an HTTP connection anymore. Can we upgrade this to WebSocket? And it'll do that for you. It'll open up a TCP port, and it'll tell you, here's the TCP port that WebSocket's on, and your client just makes that connection, and boom, you now have a WebSocket connection. SSE was the old one before WebSocket became a thing, because of proxies didn't know how to handle WebSockets since it has an extra connection to make. And the negotiation was different. So SSE was a way to provide WebSocket-like connectivity without having all of the protocol to it. I have a couple of blog posts about SSE and WebSockets and their differences on my website. If you want to, let me see if that's even there anymore. Hopefully it hasn't been hacked.
I'm still trying to wrap my head around what documentation might look if I was trying to expose or deliver documentation for this in one spot. Because I have two sides of the conversation. When I deliver RSocket client server, I am actually delivering both sides of the conversation. So I feel like maybe I need to deliver the documentation to both sides.
Yeah.
I'm not sure. I'm still getting my head wrapped around what that might look like for me.
Well, Yeah. So here's a way to do WebSocket with RSocket. So if you ever needed to worry about that, you probably don't. You probably are just going to use TCP, but it's on sudoinit5.com. It's a few tutorials with the old version of Spring Framework. I'm going to update these to use Spring Framework 6 and Spring Boot 3 in the meantime. On the other hand, yeah, documentation, RSocket. What does Bing know about it? About like what are we looking for? What is the thing that we're looking for? Like REST docs, like auto-generated documentation for RSocket services.
I went ahead and posted sudoinit5.com URL in the chat. And with that, I am going to ask everyone to poke Mario to do more blogging on the cool stuff that's inside of his head. Everybody, poke Mario.
Thanks. Yes, I will. I need to. It needs a good dusting. There's like a pile of dust on it. So somebody earlier asked about the Cassandra stuff. Like, hey, what do you do with the Cassandra implementations?
Yeah.
Those really quickly is so Spring supports the Cassandra out of the by just one single dependency. In fact, I can go through one thing, which is like here's the dependency for reactive Cassandra if you're going to connect to a Cassandra endpoint. So you use Spring Boot data starter Cassandra reactive. This will include the things necessary to make a repository work. So for instance, if you know you have a specific set of things that you want to provide, like APIs you want to provide, like find by key, then you can use Spring Data. Spring Data works automatically by just overriding the reactive Cassandra repository and then defining the types that are coming out, first by your data type and then by your key type. And then you just write your methods, find by key ID. Spring Data does the right thing. It knows that you have a field called key, and it knows how to subfield called ID. So it'll actually search for that using the power of Spring Data.
Yeah, that pattern that we see across many different persistent stores, data stores.
Yeah, and testing it is easy. Now, testing with Cassandra is also something that you're going to use test containers for. So how do we do this with test containers? Well, okay, I want to tell you guys something. I spent about 6 hours. I already had test containers tests a long time ago, okay? But what I did was I said, hey, I'm not using the real test containers. I'm using Playtica's test containers. And the reason why is because Playtica's test containers was a Spring Boot edition. And let's see where that is. Okay, so yeah, Playtica test containers is a Spring Boot edition. It allows you to hook your test container creation to the Spring Boot lifecycle instead of having to create a static class containing the container creation. Playtica's is tied to the Spring Boot context creation. Why is that? Why does that matter? Good question. So the reason why it matters is I want to be able to clean the state of the container. I do not want every test generating starting up Cassandra because that takes a long time. It takes a very long time, and I don't really have control over the state at static runtime. I can't tell the container generator. I can't say, hey, here's a particular nuance that I want to give to this container. I can't do that. So up front, I'm already at a loss. I have to like create all these classes and all these other boilerplates in order to do that. I want to be able to say, here's a particular initialization code that I want to use. I can't do that statically. So in order to get around it, I tried and I created lots of different base classes, and then I created a new project. And what I learned was statically, I was creating the container and then handing it off faster than the container was able to start. And I realized that the default test containers doesn't have a way to gauge health. It doesn't know how to go, hey, are you up yet? It just starts it, and then once it thinks it started, it keeps going with your test. And it might not be completely started yet. So what I found was that some of my tests were passing and some of them were failing. And I was thinking, why is that happening? And I found out that it was due to the nature of the container lifecycle within the JUnit 5, within the test containers implementation. And I said, oh, I can fix this, but it's going to take it's going to take some boilerplate for me to make this work the way I want it to work. In the meantime, I already have Completica's stuff working. So why not just continue using it? And so to make it work, all that you would need to do if you're writing tests that use Completica is to write a configuration, a class, create a bean, literally just create a bean, provide all your container setup in one place, right? You can set up your container setup, and then because it's not tied to the static initialization of a class, you have access to Spring beans within the container. So as long as you understand that you have to be able to say, I don't want any other bean to start until this bean is started, which is why we have depends on here. Then you can basically say, this is going to happen before this happens. That's important. So I want to be able to say, hey, the container, where are you? And what's your host? And give me your port, right? And so you could put that into for Cassandra users, a Cassandra properties. So Cassandra properties is the thing that reads off of the your YAML file, and it says spring.cassandra. Contact points dot username and yada yada yada. You're not going to get that from the container, so you have to suss that. You have to be able to pull that out of the container itself and then feed it into properties. And then telling before reactive Cassandra starts, depend on this one container to start, and that's it. So just make sure that nothing else happens that is important to your data before your container is started. And that's it. So the container just becomes a bean. Now, because it's a bean, you have the ability to do things to the container at runtime. You don't have to treat it differently. So nothing specific happens other than, I'm talking to a Cassandra endpoint, and I'm making I'm doing the truncates. So what I have is the ability to truncate in between phases. Because I'm using the same container, every test case needs to be able to have a clean slate. So there's this thing in the configuration. Is that right? No. This guy here. No, schema test. There's this guy here that before each test, it truncates the whole thing.
Yep.
So that's a guaranteed it's going to work. And that's because once Cassandra sees that it's got a template, then it lets everything else work, which SQL setup requires. This bean here actually requires a reactive Cassandra template. And I'm just using that template to read a file out of the resources directory that contains a bunch of truncates and then execute them. So that we have
admit right here for all of you, I'm going to admit, I've used this not just for tests, but I've used this same pattern, these same dependencies to attach a Redis to my application as like an kind of an in-memory Redis implementation that just went along with my application.
Oh, yeah.
So I didn't have to do anything extra. Just with my application, I'd start up, and I knew that when I started up, I had a Redis instance available. It was a singleton tied to that instance. I couldn't share it across any others, but it works. And I've done it, and I'm admitting it to you now, and I'm not going to apologize.
Here, Devin, I'm standing by it, and that's the story I'm sticking to.
I've done it. And the idea that I can do this, I can have this singleton implementation just delivered with my code is great as a start. It's a great way to get started and get out of the gate to kind of do a POC, deliver some code that works with an implementation in the back without doing a mock.
Yeah.
Right? You can actually stand up and validate it. It works. I've done it.
Well, I mean, test containers over mock any day, all day.
Yeah.
I used to have a mock Cassandra server, and then I got rid of it.
Yeah. Who wants to do that? Things
Oh,
are moving too fast to do that.
yeah, the thing is with the mock servers, you don't know if something's going to change in the underlying production server that code completely invalidates your unit tests.
Yep.
So test containers is really that much more valuable just because it validates that you're able to do everything. You're able to make the connections to a current live server rather than a mock server. A mock server will probably act like it, but it probably won't be. It won't have the connectivity options. They might change over time.
Yeah.
And those are important things.
Less confidence on that path of production. I have less confidence if I'm using mocks than I do if I'm using test containers.
Exactly.
One of the things that I want to do, maybe not today, but soon, is I want to talk about a little bit from our application, a little bit beyond what we do in this inner loop development of using our unit tests. We've done some TDD, both types of test-driven development and test-driven documentation, both TDDs, and take it to the next step. Once we do a commit, or once we get into our pipeline, that path of production, where we get into the integration tests, where we might be using test containers. One of the other examples that we've gone through is like where we're generating that native image, and we want to validate that native image before it moves down the path. I would like to get into that soon as just kind of an example. Let's show some patterns around the unit testing versus the integration testing versus the end-to-end testing that we might see on that path of production.
So like unit test versus integration test versus what's the last?
E to E or performance tests or load
Right.
tests, right? There's a lot of different types of supply chains. There's a lot of different ways we might interact. But what are some of those patterns? What might one pattern look like in an example of, hey, here's my unit test. This is my inner loop. And when I hit commit, here's what happens. Here's where the integration tests run. The difference of running those fast unit tests locally and something that might take a little bit longer as something I don't want you to do on your laptop necessarily. You should still be able to, but not every time as part of your regular development. Run those integration tests or those end-to-end tests at some later stage in that path of production.
So like the way I broke it up was I have these really small, fast unit tests that do mostly mocks, and they only prove the contracts are, stable. Like everybody can talk to each other, given the contracts that we have, right? And then the second one is, these are really small. It says, hey, do I have state? Can I hold state? Can one thing talk to the other thing? Can these things actually, emit values that do something, right? So these are very simple, just lightweight tests up front. Second thing is, I've got heavier tests that make use of implementations of those aforementioned tests. That is, the things that I want to actually implement them test, like for instance, an index. This says disabled, but it's because it's an abstract class, but it contains the amount of tests needed to certify any index in this application. So any index within this application is going to, whether it's an Elastic search index or if it's a Lucene index, it's going to use this test to prove it, right? And so being able to start from just isolated, on JVM state tests to regression, not regression, but to integration tests with the actual container itself, with the index backing, to later on standing up the full service, the thing that I will eventually deploy, and then pinging that. They'll have the same test.
Love it.
And so I can just certify that, just like we were doing with the proxy clients. I just got rid of the code that declared the client and replaced it. And so we know that it works, but we know there's some issues with what I did with all the generics. So we'll figure that out later. That's something I can just stream on my channel as I figure that one out. But the next thing is, like I showed you what the Cassandra thing is, the Playtica, the Playtica stuff, and why it was so complicated, and how I had to reset the entire world every time a test ran. And I use Playticas because I like the bean. I like the ability to hook my thing into a bean, my container into a bean. So I do the original test containers using Elasticsearch, since it's Elasticsearch comes up in a slightly different way. There's actually ways of asking Elasticsearch, are you healthy? And knowing when you can talk to it. So I didn't have to build anything new to it. So in this case, this is your standard Elasticsearch container test containers test in Kotlin, right? So in Kotlin, just create a static inner class and then start your container using the @container annotation. And if you notice, we have this wait strategy. This is the most important thing of test containers. I probably shouldn't stress this enough. But having a wait strategy and saying, hey, don't let anything happen until this guy is up is important, because if it doesn't come up and your tests start running, then everything fails, and you're going to look through a ton of logs, and you're going to find that, like, at the last moment, oh, it's the container that wasn't actually, like, a part of the container wasn't working, or maybe the transport was working, it was connecting, but maybe the server in the background wasn't. So finding all that stuff out can be kind of rage inducing. Let's not have any rage. Let's be happy. Yes. Let's wait for our containers to start up at testing and ensure that we have a proper wait strategy. So with this, the Elastic has one. It's in their website. Anybody can find it. And like I said before, with some other containers, the wait strategy isn't so understood, or at least you have to bake it in separately, or you have to find your own way of testing whether that container is truly ready to be looked at or not. Now, I know what I did wrong with Cassandra was I did not use DataStax Enterprise, and that has a health strategy. The standard Apache Cassandra image does not have a wait strategy, does not have a health strategy. So those are the two different things between the containers that you choose. So choose a container that has a health strategy so that you can spin it up and then do these things to it. By default, Elasticsearch's 8.60 and up, it contains a health check, so that on startup you can do the health check and it'll work. So that's it. So the other part of the test container setup is these dynamic property sources that only get executed after the container is started, and these are another static method that actually pushes these registry values in to a dynamic property registry that gets folded into the application context when the application context starts up. So although at this point in time, you see when this container starts, Spring has not started up yet. So it has no idea like what to connect to until like this guy here is done. So what this is doing, why this is important, is we're allowing Spring to come back and say, hey, it looks like you had some dynamic properties that I want to merge into my properties. So when Spring sees a dynamic property source, it takes that bean and it merges it to its application properties. And that happens before bean registration happens, which is a side effect that you want, since you want your resources to come up before the context decides to start making connections. And you saw the little hokey thing I did, which was depends on. And you shouldn't have to do depends on, because sometimes you don't know what other beans are going to depend on, and then you have to put depends on everywhere. Yeah. And who wants to do that? So this is, like I said, this is the right path. Okay, this is the correct path. What you saw with the Cassandra stuff probably isn't the correct path, but it works, right? So the right path is use container, create a static, launch it, do a health check, dynamic property source, and you're golden, and you're good. Hey, that's that.
Great. This is great. This has been great. We're pushing an hour 40. I'm feeling good. I feel like I learned something today. I hope that you have also learned something today. And yeah. So what are we gonna do next?
Who didn't learn anything today?
If you didn't learn anything today, raise your hand. Let us know. Also, let us know, like, what would you like to learn next? We've spent a lot of time. We're spending different sessions testing, evaluating some of the new Spring Boot 3 features, and moving forward.
I have another project that uses RSocket. All right, so okay, so let's move. Let's do one more thing, and see if I can get it to do what I want it to do. I believe I created another project before Spring Boot 3, just before Spring Boot 3. Okay. And can you see my screen?
I can. We are mobile only.
Good. Yeah, so I think this is a Kotlin project too. Okay, so I know you like Shell. I know you
Yeah.
like Spring Shell, right?
Yes, I do like Spring Shell.
Because I like Shell too. I think Shell's a really cool application. I think it's a really great way to interact with your application. My demo chat application has a shell too. I just didn't show that, but um, so there's an example out here which combines Spring Security and a shell. So what we want to be able to do is log into our shell and then provide commands to our shell that will have authority. Either you can do this or you can't do that, things like that. So in this, we have the following. We have a security context repository, and this is reactive, you guys. You have to understand that in a reactive world, there is no thread local. So you're not always operating under a thread. Instead of a thread local, you're operating under a context. And that context gets passed depending on the subscription to the stream that you're making. So if you could think of it as every time you make a step in a stream, you might be somewhere else. You might be in another thread. Every step in the stream can be in another thread or in a different machine altogether. So in order to get around that, you have to pass a context with every step. And the context is bound to the subscription, the thing that asked for the stream in the first place. So you always have the correct context to the correct subscriber. And so in the reactive world, you have security context, and you get to configure that security context by saying, hey, I want to create a security, I want to save the context within the stream, right? So within the stream, you can take the security context and you can save it to that particular step. And that's what we're doing here. We're saying, hey, I want to just grab the security context and I want to save it here. And then I want to load it. So sometimes you want to be able to load the security context. And you can do that too. You can say, okay, load me the security context, get it out of the subscriber, and say, here's the thing that I have for basically that particular operation. And then, context write, which writes to the stream itself. That's all reactive code. Now, that was the most complicated part about that, and I wanted to get over that and not harp on why that was important or not. But the second thing is, let's look at the part of the application where we enter the application, the telephone configuration. Is that the one? Is this the one that exposes an application? Which one of you is, this guy here. Okay, so enable reactive method security, right? So that's the thing that'll allow me to pass the security context throughout my subscriptions and understand which principal is currently in that reactive stream, right?
So where is your CLI user, your shell user? Where are they authenticating against?
So telephone user, okay, so here is the thing that does all of that work. So whenever you log in, you have to talk to an authentication manager. That authentication manager has both the user detail service, which is like the database of all your users, for instance. You see right here, I have a map reactive user detail service. And that contains the users, their usernames, their passwords, and all of the authorities that they have. So in this case, I have like role call and role create. And this guy here can do role receive, right? So I have Spring and I have Tux, and they can do different things. This bean here is just saying, hey, passwords, don't worry about password encoding, just let them fly. Like, nobody's trying to lock down, nobody's trying to break into this thing. Don't encode anything, just no op, right?
Okay.
Yeah. And then, and that's it. That's the thing. I wrote a authentication manager at some point, and I realized I don't need this because this is already going to be done for me in the background by Spring Security. So I don't really have any need to, provide code that's already provided. And plus, I'd have to test it, and I really don't want to have to test that type of stuff. Let me make sure that this still works. Because sometimes you don't know if those things work.
Well, this is shell client. This is something that we see, right? This is you have my head racing. This is something that we see when I use my my Google Cloud client, G Cloud, or my Azure AZ.
Oh yeah,
the CLI, where it's authenticating against some service, and sometimes it'll store like a token or something in my my local users .config gcloud, but then I can reuse that. And if that token hasn't expired, I can re-authenticate without having to do anything. But you've got my mind racing on. This is something I haven't explored in what I've been doing with Spring Shell 3.0. And this is something that I definitely need to explore a little bit further. Right there, like that idea. Like you could still do some things maybe with your shell client, even though you're not authenticated. But if you are authenticated, you might have more options available. And this type of capability, this type of feature is automatically built into that Spring Shell framework. It allows you to say, hey, these methods are available if you're logged in, and these are not. And that's just another feature of Spring Shell.
Am I doing this right?
I don't see where you're typing.
Oh, okay. You can't see that. It's at the bottom of the screen. Oh, okay. I get it. Okay. Is that how you type in? Is that how you push arguments?
Yeah. You know what else you can do? Yes. Do login tab.
Oh, that's it. Oh.
Ooh. Another feature just made as part of the framework. Do help. I don't know which version of Spring Shell you're using, but if you type help from within the shell, you automatically get a listing of all of the endpoints.
Oh, there we go. Okay. Oh, I see. Reactive -who.
Here, I'm going to switch it so it'll be from your screen here.
Okay.
There we
go. So as you can see, I did a who am I, and so what happens is the Spring. This is I'm in a reactive session. I'm actually using reactive operations against a non-reactive shell. It's an imperative shell. So if you notice, everything is blocking. But the idea is I want to be able to say, all right, every shell method is going to be represented by a reactive stream that eventually blocks and then, puts you back into the shell. So that, you don't, so it's not completely asynchronous, because if it was asynchronous, you would hit reactive who am I, and even if it took a second, it would return to shell immediately, but then it would start printing out what you asked for, and I didn't want that. All right, so we can see that I'm logged in, and there are certain things that I can do. So let's see what I can do here. I'm going to do something I shouldn't be able to do, which is receive.
Yeah, type help again.
Oh, I must have, yeah. Maybe I did. Maybe I changed something. Receive as a repo load on call queue stream for each. That used to work.
Yeah, well, it should be checking availability logged in.
Yeah, checks logged in. It says, hey, you're logged in. You're not logged in.
It's checking if you have the role, and you don't. So it says.
Oh, must be an instance of publisher. So did I not type face it? Oh, okay. So it needs to be a publisher. So I shouldn't block that. Yes. So do not block that, Mario. All right, let's get out of there real quickly, and let's do this again. So what happens was I didn't block it, or I did block it, and well, I guess it doesn't want me to do that. I haven't. By the way, I haven't opened up this project in.
That's okay.
I would say.
I'm gonna help you fix it.
Okay, so I got a mono flat map here.
But you shouldn't have been able to.
Maybe. Yeah. So only Tux can receive. Why is this guy here doing that then? So let's go back to user commands. Hi, is that user commands? No. Let's go back to user commands. I said, hey, where am I? I said, a bunch of user commands. Let's go back to telephone commands. Yep. And I have role receive, and I received a mono flat map. Now I don't expect to be able to do that.
Oh, wait. Go back.
Again, I'm getting that same error that I got before.
Scroll down. Scroll down.
Oh, it wants publishers, so it doesn't want me to block. Okay. So I shouldn't block for any of these calls. All of these calls should be unblocked.
Go down to the check login method.
Check login here.
Yeah.
Yeah, that's my shell method availability. Whether I can do it or not. If I just rerun it and let's see. I haven't run this in a while, so I might have changed some things before I left it as it is, and I might have to change them back, which is maybe those block commands were not supposed to be there. But in the long run, I'll figure out something. Let's see if I can do receive now. So yeah, I'm getting null pointers because most likely the repo doesn't have anything, and I don't have any. I don't have like a throw check saying, hey, you're not logged in. It just throws you a null pointer exception. So at this point, you kind of have to log in in order for anything to work. So, okay. So I have a receive, and then if I did a call minus what? Username, tux, message, hello. Okay, so that's a mono. So let's go back into here. And let's do Spring Boot run again too. This time, right? No, I'm not connected to a server. I have to log in to Tux. This is a standalone server. I'm sorry. This is not an RSocket server. This is a standalone server. So let me go here and say, Tux, what is your password? And configuration is still 1, 2, 3, 4, 5. Okay, and so if I said receive, okay, great. So yeah, I don't see anything out of Tux. I did something. I made it. I made this the way it is because it was a POC for Spring Security and Shell and reactive security. I was able to get to a certain point, but I do remember being able to make telephone. I do remember writing telephone calls in here. However, I know I've made a couple of changes that I was pushing the boundaries at some point and said, hey, I want to be able to do some other things. And if you notice, even the things like reactive who am I have changed because it used to be just who am I and it wasn't reactive. And then I said, hey, let's add reactive and let's see how it reacts to that stuff. And I think I know I made a change. Let me see if maybe my GitHub Git status.
It's okay.
Oh yeah, we did make a lot of changes.
You've opened up my mind on the shell, or actually another use case for the shell, like that whole login. My question to you is: let's say I'm using Spring Authorization Server to log in. I'm going to send something back. I'm going to send back some token that says, "Hey, yes, you are authenticated." I think I'm okay with sending back a JWT or something that says, "Hey, yes, I'm authenticated," so that that client can store it on my local file system in my user.config, so that the next time I log in, the next time I use the shell, I can validate, hey, have you been authenticated? I want to do that example with Spring Shell. I want to run that example with Spring Shell. I want to demonstrate that example with Spring Shell. Because we're having this conversation about different clients, the HTTP client that we've created, an RSocket client that we created. Well, now we have another, probably the most popular, most powerful client is that shell client.
Yes.
And have it being able to interface, like maybe I have a Spring Cloud Gateway in front, having these different ways of interfacing with the same service, the same functionality on some system. That is, I think, something that I want to explore with this shell.
Oh, look at, there's more in here, dude. Like, I was busy. I don't know what's going on here, man. What in the heck? Okay, so in the README for the other project, it was like, hey, this is an older complete project. It didn't satisfy a requirement in preparing a local security experience. See the adjacent project which utilizes RSocket. Okay. So that's why it's like it looks weird. It's incomplete. Okay. All right. So we have that. What is this? What is going on here? What am I supposed to do?
Run it and let's ask it for help.
This is an RSocket based one as well. So what I'm thinking is going to happen is I'm almost sure that it's going to want to make a connection, and I might need to feed it a parameter in order to make. Oh, hi. Oops. Help. Okay, there we go. Oh yes, this is the tree one. This is where you have rake and shake. You have a tree. You can either rake it or you can shake it. One user has rake, the other user has rake and shake.
Right.
Okay, so who do I log in as? How can I log in?
So what does that asterisk mean? The asterisk means that that method is not available to you.
Oh yeah, you're right. Show method availability. Check logged in. I'm not logged in. Ah, cool. Okay, interesting.
Cool
When
stuff.
requester is present, so I must connect to a server. Okay, so login, username, password. Optional of requester factory requester username and password. That logs it. Holy moly.
So let's go to your.
Holy moly.
Do you
Who
have
does this?
the user details anywhere?
So do I need to like? Do I start an? Okay, so what do I want to do? Tree service security.
Did you create that user details?
Security configuration, simple security authentication. Don't know.
Right. Security message handler, custom.
Okay, there's more stuff. I don't know. Let me see. Maybe I don't need to do anything. Maybe I could just log in and it's logged in. Maybe it only takes login.
It looks like it needed a user password.
Oh, it does.
Yeah.
Oh my gosh.
I don't know where you defined it.
Yeah, where am I going to get that from? Username gets passed into username password metadata. Oh, that gets set up into the metadata. Huh?
Oh, is it in your application properties?
Maybe so. Spring trees, RSocket port 8199.
Look at your.
Hold on, let's see what this is. Requester. What is this stuff?
This is just in your tests.
These are tests, but it's making use of like
where did
all
you
of
do
the
that
components
for your service?
Yeah, it says AutoWide requester factory. Here's a requester factory. How is that supposed to work when you? Oh yeah, because you don't need the extension to do that. Will that work? Yeah, I didn't think that would work. I'm like, no, dude, that's not gonna work, man. Failed to bind on port 8199. You know why?
Because the other one's running.
That's right.
Yeah.
Okay. There you go. Okay, so this starts on port 8999 like it's supposed to, but what does it do?
And I want to ask you one more.
Okay, so whatever happens here.
Okay. So your test does an implementation and it runs through a conversation, but your implementation doesn't set up any user details. Will you do me a favor? Will you look at your application.properties?
Yeah.
Real quick. I just want to in the main, not in the.
Oh, main. Yeah. Yeah. That's just the name of the application and the port that it's going to be sitting on. And method security tests. Oh, dude, I didn't do that. Somebody else wrote this. I'm sorry. Oh, yeah. Look, there's like mock users.
Yep.
That is so cool. Oh, cool. So like that is so cool. Mock user will inject the user into the service, the tree service. What? Oh, that's just messed up.
Go to your tree service impl.
Sorry?
Go to your tree service impl.
Is there a tree service impl? There is. Oh, okay. Wait. Okay, wait. Where's, you know what we need? Message mapping. So that's this part here. Here is status for authentication principal.
Mm-hmm.
And tree service security, which has pre-authorize. And then tree service impl is a standard tree service, of course.
Yeah, but we still don't have a.
And here's the user detail service.
There it is. There's your user detail service bean.
Server tree controller contains tree controller mapping, tree service security, tree service by tree service implementation. So this is another one of those really crazy, gnarly subclass. Like we're going to squash all the dependencies of the annotations into one place. That's what's happening here. And Kotlin has a really cool by keyword. You know, in Kotlin, if you have like an interface that you want to implement, but you don't want to like write the implementation based off of a class that implements that implementation. If you want to like say, here's a surrogate for this implementation, then you can say buy, and you
Yep.
can give it an actual implementation, and that'll give you that surrogated implementation. So like this controller becomes a real controller because of the implementation in it.
Well, now you can run it again, and now you've got your user detail service info.
Oh, now I know what servers I have. You're right.
Yep.
I mean, now I know what users I have. I have Shaker, I have Raker, and Connector. And I really only have like check. I only have like 2 commands in here. I have login, and I should just have rake. Yeah, I just have login and rake. Where's shake? What happened to shake, guys? Did we get rid of shake? I guess we got rid of shake.
Well, baby steps.
Baby steps. Yeah, we used to have shake. I know somewhere has shake. Maybe that's in the previous project. I wonder if they've finished this. Okay, so let's go back into the app. And here's the app. It has a shaker.
We want Raker.
Password, no password.
Oh, no. Shaker can shake. Oh, it looks like Shaker can rake. Rake only check to see if you were able to. Yeah. Rake. I don't think Shaker can rake. I think you got to log in as Raker.
Ah, that's better. That's what I'm looking for, buddy. Access denied.
Boom. Nailed it. All right. Proof's in the pudding.
So let's do this one. Let's log in as Raker and see if it still does the same thing.
No, Raker can rake.
Oh, there
Raker can rake. Raker can rake.
He rakes leaves. Interesting.
One at a time.
One at a time. One at a time. It's supposed to rake leaves, and then it's supposed to grab leaves. Now, here's the idea. It was just verbs that returned like random data. So let's see what happens if I log in as Shaker and I type in shake. Well, shake just no, it doesn't.
No, that wasn't available.
Shake, and like that access denied error can be completely fixed. We can get rid of that. All right, but
we can also in our check availability. My kids just got home, so I got to jump off. But we could have done a availability check to say, hey, do you have this role, to see whether or not you can do that method.
What does that mean?
Where you did on your method. On
the tree command?
Right here, where we do that shell method availability.
Yeah.
On my check logged in, I could do check logged in and check user has role. So not just whether or not you're available or you're logged in. I could also say, are you logged in and do you have this role, to decide whether or not that method is available.
Well, that's a good. That's a good question. Yeah. Can I just put pre-authorized there? Right. Like, will that work? Can I get rid of it?
That won't do the same thing. That will not remove that method. It won't put that asterisk on your CLI that says, hey, you don't have.
Oh, yeah, that's right. Okay, so that won't prevent me from executing it.
Yep.
Oh, okay. Okay. Okay, hey, so that won't have an effect that I want.
I have to jump.
Okay. Well, thanks for having us, me, and I enjoyed this couple of hours.
Thank you for having me. I'm already looking forward to the next one. We have been having fun. It's 2023. I think that it's safe to say that code is back, and we're going to continue doing this and exploring the ways that we can leverage the Spring framework to move us forward. Like, let's get to production.
It's on.
All right. Thank you so much.
Oh, Lord.
Thank you, everybody that joined.
Oh, my Lord.
We had a high watermark. We had people from all over the world. It was wonderful. And and I know that the show it picks up people throughout the week, but stay tuned. We'll figure out when our next episode is coming. And until then.
Oh, wow.
Thanks.
Yeah. So somebody wrote a blog, and somebody needs to publish the blog.
We're not pointing any fingers.
Not pointing any fingers either. But what the heck? I'm surprised that this is even there. I remember doing it, and then I don't remember writing the doc.
Let's get it done.
That's weird. I'll try to figure out something. There are multiple things here.
Yes, Victor, thanks for joining. We appreciate you.
All right. So what I want to do is actually see that requester there. That doesn't need to be a requester. That can be a a declarative client at some point. Like, why not?
That's what we have to do next. That's the obvious next evolution. And I was going to say this palm right here. We need to upgrade to Spring Boot 3. We need to upgrade Spring Shell to Spring Shell 3.
Using 2.7.3.
We've got that's our next episode is writing itself.
Oh whoa! I'm using
like
a very old version of Spring, you guys. This is from like yesteryear.
But we need to get it upgraded.
Holy moly!
Until next time.
Is that all I need to do?
Everyone. Nope. I also want you to upgrade your Spring Shell version. You're using 2.1.1. Shell version 3.0.0. It is GA.
Oh my god.
Yeah, we got some changes here.
Oh my god. Well, you didn't know that. You didn't see that. I didn't make any code changes that put it back to 2.11.
But now we can go back and we can do the same things that we did at the beginning of the episode in changing our client to be a declarative client.
I had no relations with that client.
It's okay. It's okay.
Famous presidential quotes for 500.
We're moving things forward.
Yeah.
Mario, thanks again.
Thanks a lot, man. I learned something here. I gotta upgrade, and then write that documentation. So that's cool. We're gonna get that done. I love documentation. I love RSocket documentation, if that's possible. Also, and, the hunt for this whole declarative client thing that I have a demo chat will turn into like a post somewhere.
I have a strong request. The Spring Office Hours community, we've been talking about you for weeks, months. We need you to come into a Spring Office Hours and join us.
Yes, I will happily show up. I want to. I like doing these things when I know that the end result is not me debugging for an hour and a half. Yeah. So what I want to do with you guys is when this whole RSocket thing happens, when I'm done with the RSocket, like really nuanced, generified clients, then I could show that on office hours. I would like to do that as a way of saying, hey, remember that time I was working on this thing and we found this gnarly error? Well, here's the fix. This will be one of those like learning moments. So delicious.
Yeah. We all want to know. We all like there is good stuff to be learned. And I would like to learn it from you.
Yes, we're learning. We're both learning. We're learning from each other. I'm learning more from you here. But
let's go
here. Like I barely know how to use Shell, and you're just like, hey, no, don't do it that way. Like what?
We're gonna have fun. Again, everybody, thanks for coming. We will see you again real soon.
Bye, everyone. Thanks for showing up. Also, don't forget to check out Office Hours.
Office Hours. SpringOfficeHours.io. Code.
And code. And check out DaShaun's channel. He has he's been coding. He's up there coding it every day, all day. Bye.